Can you guys hear me? Hello? Okay, cool. So I guess we'll start. So hello, my name is John. I'm a PhD student from the University of Toronto, and I'll be the moderator for this session on language evolution. So in this session, there are 5 talks. They're 15 minutes roughly each, and they're followed roughly by 5 minutes of Q&A, where questions will be offline and online. So there's some key housekeeping notes. So the session is live streamed and recorded. Masks are encouraged. And please switch off mobile devices to switch them to silent or vibrate. So, okay, cool. So for the first talk, we have Carmen Saldana from the University of Zurich. Who will be presenting virtually. I don't know if they can hear us, but
yes, I can. I don't know if you can hear me.
Yeah.
Can you hear me?
Yeah, we can hear you, but we can't see your.
Not the slides.
Yeah, we can't see your slides.
The people in Zoom, I think, can see them.
Right. So what I'm gonna do is I'm just gonna connect my computer to the projector. Oh, never mind. It works now. Cool. So take it away.
Sorry. Does that mean that you can see my slides now?
Yeah, we can see your slides.
Okay. Good. Thank you. Okay. Hello, everyone. My name is Carmen Saldana, and I'm going to be presenting some joint work with Borja Erte and Baltzar Bickel in the University of Zurich. I'll first start by saying something about the framework that I use normally. So my research focuses on looking at the impact of individual biases on typological distributions. And the assumption is that if there are some underpinnings, cognitive underpinnings, to the typological distributions, we would be able to see them on acquisition and production, because that's the only way that they can permeate the system from individuals to the system that later on would be actually the system that the individuals learn also. So the question is, how do we test the impact of these biases in acquisition and production? And what I do normally, I use lab and online experiments in artificial language learning that can allow me to uncover these biases in control environments. Okay, so in this talk, given this framework, I'm going to be focusing on morphological paradigms. And in particular, I'm going to be talking about unnaturalness in paradigmatic splits. Hopefully, unnaturalness and paradigmatic splits become clear later on. It's based on 2 papers, one that it's going to be published in OpenMind and the other one that it's just submitted, but you have a summary of both in the link of the Coxeye proceedings that I just put on the chat. So we're going to start with the patterns of syncretism, and let's focus, for example, in a paradigm that is a 2x3 here. So we have a number feature and a person feature, and that number feature has 2 values, singular plural, and that person feature has 3 values, 1, 2, and 3. Okay, this is also a verb paradigm. So here it could be like verbal agreement to the subject, for example. So in the case of English, you could have go, go, goes, and go, go, go for the verb to go. So that doesn't give us many different forms, but in Spanish, you could have 1 for each, for example. So that could be something like this paradigm. And in other languages, you can have certain cells having the same form and some other cells not. And those patterns, like those cells that have the same form, we would call that syncretism, because those are morphosyntactic categories that are not being expressed differently in the form, okay? I'm just giving an intro just in case that's just not clear when I say syncretism. So these distributions of syncretism across the paradigm are not random, and they tend to conform to what we call natural classes or natural patterns. So for example, here is an example from Dutch. And what we can see here is that there's a verbal form for the plural, regardless of the person, that is the same, right? So that like first person plural, second person plural, and third person plural have the same form. And that is a syncretic form across plural, right? So they all share a value, which is plurality here, okay? So that's a natural class, and that's easy. We call that a paradigmatic split because somehow there's a split on these three forms versus the other, whatever they do. In this case, there's a syncretism in two singular and three singular, but not in one, but we're gonna forget about that for now. So this is the majority of the cases. We have natural classes, but there's also patterns that contain unnatural classes or natural patterns. And those are actually not exceedingly uncommon, especially in Romance languages, if you're familiar with those. And when they exist, they're actually quite robustly transmitted over time. And these kind of unnatural patterns can be of forms like this. So for example, this is an example of Hindi. And here we can see that there's syncretism for two singular, three singular, and two plural. In this case, we cannot say that there's a single value that it shares amongst the three forms, the three cells here. So it's not considered a natural partition. And another example could be here from Capao, that's Papua New Guinea. And here we can see also that there's syncretism in two plural, three plural, and four singular, which is also, those cells don't share only one value, okay? There's no a priori reason to believe that all these unnatural patterns occur with the same frequency in the languages across the world. We know that natural classes appear most of the time, and actually syncretism in verbal paradigms is very, very likely. But we don't know much about the gradients of the distribution of these unnatural patterns. So how unnatural are those? If we look at it more closely, and that's the hypothesis that we had, is that they might be a gradient of naturalness depending on how many feature values are shared across the cells, right? So we could think of it as a category learning strategy here. So for example, in what we're gonna call the L-type pattern, and that's merely because it looks like an L, and they're very common in Romance languages, we see that two cells here will share a feature value. I don't know if you can see my cursor. Can you see my cursor? Okay, thank you, Kenny. And these two cells here would also share feature value, right? So there's only this pair that will not share feature value. And if we compare to these ones over here, we can see that there's going to be two that share feature value here, plurality, but these two and these two won't, right? So if we calculate the overall amount of feature overlap, there will be a gradient, right? Now the question is, do we see like an asymmetry between these patterns of unnaturalness and how unnatural they are, right? So the first thing that we did was actually look at the cross-linguistic distribution. So as I said, patterns of syncretism that are natural are very rare. So from Borja's and my colleagues' database, there were only 15% of 500 languages. And we took his database and another database by Berman of syncretism, and we looked at the count there. So this is the rough count that we found on L patterns and X patterns. So X are the most unnatural in terms of feature overlap, and the L patterns are the less unnatural. And we see that there's more of the L-type patterns, so those that contain a bit of overall higher overlap, okay? So this is what we found typologically. We said, okay, so maybe there is actually a gradient on how rare they are. And we had a question is, can that typological symmetry reflect a learning bias towards this similarity-based structures, here similarity being feature overlap, right? Can we find like a cognitive correspondent to this typological distribution that we found? So what we did is we designed an artificial language learning experiment, and we had three conditions for syncretic patterns. So here I used the grid that I used before for the number and person verbal paradigms. So here I'm showing suffixes, right? That could be the subject agreement with a pronoun. And in this case, we have a natural pattern. So we have gu for all the plural forms and na for all the singular forms, regardless of the person. And here we have all the possible combinations of L-type patterns where they're mirror images because we wanted to have it as controlled as possible. So in this case, we have a split of the paradigm that is exactly the same. So in this case, the split of two L patterns. And this is here, the X pattern is a split with two X patterns, okay? So they're just the blue and the orange are just mirror images, really. So both of them are X patterns in the X pattern condition, and both of them are L patterns in the L pattern condition. Same with the natural. Okay, and we wanted to see whether there could be that gradient that we found in the typology also would have reality in learning. We also wanted to compare them to a non-syncretic condition because, as we can see, syncretism is quite spread in verbal agreement paradigms. And we also wanted to see when it could play, like when it would be favorable to learn non-syncretic paradigm, given that it has a lot more endings. So you have to remember more forms, right? So at what level of the complication of the syncretism or the unnaturalness of syncretism, it pays off actually to learn not syncretic paradigms. Yeah. Okay, so what we did is a very simple experiment. So we just trained them in a lexicon that had only pronouns and actions, okay? In this case, we based the pronouns on Tog-Pisin with a bit of modification to make them compositional. So first, second, and third are mi, yule, and then for the plural, we just added pela. And then the actions are 3, and they're based on Basque nouns. So this is the lexicon that they learn, and that's the only thing that we train them, test them on, and check actually how good they were at learning this. And then they went into the testing phase, which is the critical part, in which we show them a combination of the pronouns and the actions, right? So here we are teaching agreement paradigms, and it's going to be a feedback learning experiment. So that means that we don't train them on those agreement paradigms. We just give them options. In this case, for example, they could see a pronoun and an action. They see 2 options of the action with the suffix na or the suffix te. They have to select one. And if it's correct, they're told that it's correct and they get a bonus reward. And if it's not correct, they're told that it's not correct. And they basically figure out that the other one was the correct one. So this is what we call the feedback learning, that participants have to choose between 2 verbal forms and then learn from that feedback. And they do that of 10 blocks of 6 trials. Every block has all the possible cells of the paradigm, okay? So all the person number combinations. So that's 60 trials in total with no division in between. So the blocks are invisible to the participant. So these are the results that we obtained for the syncretism experiment. And here we show the overall accuracy. The orange is a natural one, L type blue, X type light green, and then the yellow was a non-syncretic one. So we expected to have natural more learnable over time than the L type, and the L type more than the X type. And we didn't have a clear idea of what the non-syncretic could fall. Okay, but what we found is that these are the worst learned. And there's no difference between non-syncretic and X type, but there's a gradient. So L type is more learnable than the X type, and natural is more learnable also than the L type and the average. Okay, so we found that gradient that we discussed, and also we found that having a non-syncretic system doesn't really pay off, and it's learned in the same level as the most unnatural case of syncretism here. Okay, so as an interim conclusion here, we found the gradient of learnability that's proportional to the hypothesized gradient of unnaturalness. And we propose that this preference is driven by a bias that we call similarity-based structure, but it's actually coming, like in other domains, has been called by different names, including convexity in concept learning, or like in category learning with many other names. And we find that that's coherent with what we call the similarity-based structure. And the next question that we had is, how general is this bias to paradigmatic splits? So we've looked at syncretism, but what if we look at another phenomenon? So at the end of the day, we're doing a categorization task here, right? And does it only apply to syncretism in paradigmatic splits or another type of splits? So for example, by syntagmatic similarity. I'm gonna explain what I mean by syntagmatic similarity. That's not straightforward. So we call these positional splits. And instead of looking at the form, what we look is at the syntagmatic arrangement of the affixes, right? So for example, here in Baura, that's in Bolivia, we have a marker here and a prefix that it's a prefix across the board. So here we don't care whether they have the same form or not. we just care about, do you have an affix? Is it placed in the same position? Does it have the same slots? Okay, so in the case of Baude, you have only a prefix across the board. Here in Gumer, which we call also a natural pattern here of positional splits, we have on the singular forms, there's only a prefix, and on the plural forms, there's a circumfix, which actually cannot be derived by just a prefix plus a suffix of plurality. In Coasati, again, we have an example here of an L paradigm. This doesn't correspond exactly to this, sorry, but there's a prefix in this gray cells here, and a suffix in the first singular, and nothing like zero marking on the third, right? And again, we can look at that in X patterns, and that's an example in Basque that we have like prefix and suffix in these 3 cells highlighted here, and in the other ones, we only have a prefix or like more affixes than in the other ones, right? So here what we care about is like where are the position of the affixes that are agreeing with subject. Also with also with object, but that's not relevant now. So we're looking at how person number agreement, whether subject or object, is marked. Is it in the same place? Is it not? And if it's not, it's a split between the paradigm. And we are looking at those patterns that are split, okay? Hope and that's clear. So again, this was a bit harder because there was no data on this at all. So what we did is actually look in the source available and also collect more data. So we wanted to look whether there was actually a gradient in the typology too. And we looked at the person number cumulative verbal agreement markers in a sample of 227 languages in 97 stocks. They were taken from altitude, but also we collected additional 100 because there were not enough based on the whole sample. In total, we have 128 cases of paradigmatic splits, 88 languages, 41 stocks. This is the map of the organization. We can see that obviously most of the time we don't have paradigmatic splits. Most of the time when there's person number marking, it's going to appear in the same position, right? So the green dots that you see here on the positional splits are the times that are rare, and that doesn't happen. And those are the ones that we're looking at, okay? Yeah, I don't think I need to leave this longer. So we did the same thing and we counted the type of patterns that we saw in the positional splits. And if we look at the total counts, and here we do have the data to do the difference with the natural, we count 44 for natural, 73 for L type, and 24 for X type. So if you look at it, you could say, okay, actually L type is more common than natural, but that's actually not the case because all the logical permutations that you have within the paradigm differ depending on the patterns, right? So the L type pattern is more likely to appear by chance, right? So what we did is compare that to a baseline. And here we have the orange line would be the typological data, right? So we can see that in natural patterns, the typological data occurs, like natural patterns occur more often than in the baseline. In L type patterns, they occur roughly as you would expect by chance in the baseline. And in X patterns, they occur less than what we expect by chance or by the baseline, okay? So here we have the gradient in typology compared to a baseline, okay? So again, we got that, like this asymmetry between L type and X type in typology cross-linguistic. And we decided to do the same experiment, but with positional splits. So here's the same design. The only difference here is that instead of having syncretism, we have one affix form that is different for each cell. And they're going to be prefix or suffix. So the split is going to be whether you're a prefix or you're a suffix. Here, the blue ones are suffixes and the orange ones are prefixes. And we expect the same gradient. And then we also compare it with a condition with no split, okay, where everything is just suffix or everything is just prefix, okay? Those are assigned randomly, but this is just an example. And the lexicon is the same as we had before. And we did exactly the same. So now we have also feedback learning, 10 blocks of 6 trials, and same procedure. Here are the results. So what we see again is the gradient that we expected, which is, well, first of all, that the no split is the most learnable. That's the most they are most likely to find across the languages of the world, they all suffixes or prefixes if they're marked. And then we have the natural partition to be more learnable than the L type or X type, and L type also more learnable than X type. So this is the overall accuracy, and here you can see the trajectories through the blocks of 6 trials, and we see the same gradient. So as a conclusion, we found again the gradient of learnability proportional to the hypothesized gradient of naturalness. This, we say that's by similarity-based structure bias. And this actually robustly applies across phenomena and paradigmatic splits in our task, which actually it's personalized in the same way, but it happens in typology and in learning in this case. So that is all from me today, and thank you very much. And
okay, thanks, Carmen, for the presentation. We have roughly 2 minutes for questions. So we'll start from on-site participants. Does anyone have questions? Do you want to come on here? I'm not sure if they can hear you from the back.
Hi, thanks for the interesting talk. I have a question about the first experiment. So one possible advantage of a non-syncretic system is that it seems like it's more informative. So like each case like uniquely conveys some meaning. So in the experiment, there wasn't really like a communicative pressure. Like you just had to get the form right. You don't have to care about if someone's understanding you. But do you think that informativity might introduce like some other bias towards non-syncretic systems?
yeah, yes. So that's been heavily research and like how communication actually get operationalizes the pressure for communicativeness, and yeah, so like informativeness could be required in communicative context. We need to remember also that these are verbal agreement paradigms. So normally that information, but especially depending on how you apply it, but if not a prod drop and you don't drop the pronoun, then it's still there. So that also depends on the system that you choose. But yeah, of course, like that's what we wanted to have there. This is only a learnability pressure. This is the only thing that we're testing here. But you're very right that those things differ depending on the phenomenon that you're looking at, depending on the information in the context, and depending on the pressure. Yes.
Thank you.
Okay, thanks. So we have a question from online asking, do you think that the same types of individual biases would hold for child learners?
That's a very good question. It's very hard. So we have some purpose here in the department, which is actually quite golden, but it's very hard to test this in natural data. It would be easier to test it in an experiment, and I think we probably would get similar results because of the task is very similar to a category learning, and we've seen that also in children. But it would be very interesting to do the experiment. I expect that to happen in the experiment too. I don't know if I'm going to see it in corpus, and we try to look for it because, first of all, there are very few languages. Well, in the case of the Romans, they have L type, that X type, or it's very rare. And it's hard to track the development of the acquisition of the system to have enough data. So, but I would expect it to be the case also, yeah.
Okay, cool, thank you. I think we're running out of time for the first talk. So for the interest of time, we'll move on to the second talk.